All right, so this is section 6.1, slope fields. It also includes something called Euler's method, but that's a BC topic, so we don't have to worry about that. But slope fields is basically, have you guys ever seen how sometimes in a physics class, they'll throw a bunch of little magnetic pallets on a table and then put like a current through that table, and it creates like this weird shape, like usually circular shapes of different things, okay? And I'll see if I can find a little video of that a little later, but it creates these magnetic fields, right? So you see like the way the magnetic field actually flows based on whatever current they're using. That's kind of what slope fields are, okay? It's a small depiction of the slopes of the function, okay? Now the very first page that we have, just so you can see, is all based on these slope fields. Okay, so there's 6 of them. I'll go over 3 of them. You'll do 3 on your own. Okay, so they want us to draw a slope field for each of the following differential equations. So here's how you do it. They gave me dy dx, so that's my slope. And all I have to do, and this takes forever, by the way, so I do apologize, but this is something you need to know how to do. You're going to pick an x and a y value. Okay, so how do you pick them? Well, just look at your graph that you're given, right? So let's start at this point right here. Okay, that point is -3, 2. So this is the part where I say you guys are going to maybe have to do some calculations. So if I pick the point -3, 2, what's the answer to my slope? So -3 for x, 2 for y. So what do I get for my answer for my slope? I'm plugging in a -3 for x. A -2. So what I'm going to do, I know that a line like this is like a -1, right? So I want to draw like a slope of -2. So something more like this. Okay? And that's it. I just got that part done. And now I got to do the next point. So I'll move down. -3, 1. What's my answer? So I'm doing this point right here. Is it positive or -2? It should be -2. So I'm going to draw this again. What about at -3, 0? Do you notice a pattern right now? Anytime I do -3, notice there's no y value in that problem, right? So it doesn't matter what my y value is. What matters is what my x value is. So at every place where there's going to be a -3, it's going to look like a slope of -2. So that's what I do. All right. What about when I go to x equal to -2's? What do I get? -1. So let's do -1's. Okay, you're just watching. You don't have to draw anything if you don't want to. There you go. -1's. What's going to happen when I go to -1? 0. Okay, what about when I go to 0? 1's, right? My x value is 0. That means my slope is going to be 1's. When my x value, so like I go to 1, 2. Again, the y value doesn't matter because I don't have a y value in my slope, right? So if my x value is 1, what's my slope? 2. What's my slope when x is 2? 3. So you're just kind of drawing it to the best of your ability. And my last one's going to be like a 4, so it's going to be pretty steep. Look at this picture. What do you think the graph that this slope field what does it look like? Can you tell? It looks like a parabola, right? If you were to integrate x plus 1, what would you get? X squared over 2 plus x plus c. So it is a parabola, right? But yeah, like you would kind of draw like this, right? Skimming off of the slopes, right? That's kind of what it would look like. Now, they're not making you do that right now, but there's a slope field, okay? Let's do number 2, one that has just a y value, okay? But was that one okay? Was that pretty easy? right? I mean, not bad. Just plug in numbers and check. All right. All right. Question number 2. dy dx equals 2y. So I'm just going to pick numbers again. So let's start with the top left corner because, yeah, you do have to calculate all of them. This is why I say, like, I apologize. It's kind of annoying, but every once in a while you'll find patterns and you're like, oh, all these are going to be like this, all these are going to be like this, etc. So 2y. If I start at negative 3, 2, what do I get? 4. So this will be a positive 4, so it's going to be pretty steep. Okay? If I go to negative 3, 1, what do I get? 2. So there has to be a little bit of a difference from when you're doing stuff, okay? So just be aware of that. If I go to negative 3, 0, what do I get? All right, if I go to negative 3, negative 1, negative 2, and then negative 3, negative 2. All right, so, okay. So that doesn't look like it's the same, right? Let's go to negative 2, 2. What do I get? 4. And negative 2, 1, 2. Negative 2, 0, 0. Are you seeing a pattern right now? Yeah, which way is it going though? Instead of going up and down, left to right. So that means that my next one should be a negative 2, and the one after that should be a negative 4. Now just to kind of check, let's go somewhere else. We'll go to 1, 1, 2. If I go to 1, 2, it's still 4. If I go to 1, 1, 2. If I go to 1, 0, flat. If I go to 1, negative 1, it's going to be a negative 2. And then, let me kind of fix that here. And then this will be a negative 4. So that means these are probably all going to be 4s. These will all be 2s. These will all be 0s. These are all going to be negative 2s. And these will all be negative 4s. What kind of function do you think this is? Any guesses? Just as you guys think about it, okay, let me show you something. Because this is how you find out what it is, right? You're going to integrate if you want to. All right, so this is going to be a part where you're going to learn how to do this stuff when you start studying for your AP, but we got to solve for y. Now, whenever you get a plus something, you guys know this, right? Like if I do x squared times x cubed, we write x to the 2 plus 3, right? So e to the 2x plus c is really times e to the c, right? And what's e to a constant? It's just a constant, right? Yeah, because it's 2.718 to the some numerical power. So it's just a number, right? Here's the key. What kind of function is this? It's exponential. Some of you guys were saying, man, I noticed there's an asymptote there. Does e to the x ever cross the x-axis? No. There's your asymptote. Right? See it? It's flat right there. Can't pass through it. Okay? The reason why they show above and below is because the function could either be a positive power or a negative power. Right? Depending on which one it is. It could either go like this, like from there, or it could go like this. Or, I mean, the function could also be like one that runs a little further out. You know, it might go like that. Or something a little shorter. Okay? So that's an exponential. And I just kind of proved it to you by doing the whole set of work, right? To double check. So the last one we're going to do is going to be a 2 variable. So that's going to be number 3. Excuse me. So, all right. This one, it does matter my x and y value, right? So let's start with -3, +2. Okay, -3 for x, +2 for y. What do I get? -1. So it's going to go like that. All right. -3, +1. -2. -3, 0. -3. -3, -1. -4. And the next one's going to be like -5, right? So there's kind of what it looks like. Maybe I'll make this one a little bit steeper almost, right? All right. -2, 2. What do I get for -2, 2? 0. What do I get for -2, 1? -1. What do I get for -2, 0? It's -2, right? So notice, is this hard work to do? No, it's just annoying, right? But it's not hard work to do. -2, -1 will be -3. And then this will be -4. Okay, next one, -1, 2. So -1, 2 will be 1. -1, 1, 0. -1, 0. Okay, are you guys seeing an asymptote popping up right here? Right, it's right there. It's gonna be diagonal. Okay, but if I go to -1, -1, I get -2 and then -3. Okay. So let's go to 0. 0, 2 will be 2. 0, 1 will be 1. Guess what my next one's going to be? 0, because that's kind of the pattern that you're seeing. And guess what my next one's going to be? -1, then -2. So there's always patterns to it. You just got to kind of figure it out. Okay, so we'll go one more and then we're just going to kind of fill it in. So if we go 1, 2, that's going to be 3. If I go 1, 1, that's 2. If I go 1, 0, that's 1. And if I go 1, -1, that's 0. And if I go 1, -2, it's -1. Okay, so you'll notice there'll be a 0 there. There'll be a +1 there and there. There's going to be a +2 there and there, a +3 there and there, a +4 there and there, and a 5 there. So this function, just so you know, looks kind of like this. I'm going to kind of draw one. That's what that function looks like. Okay? But they're not asking you to draw this one, okay? Usually they'll be very specific and they'll say draw the differential equation at a specific point. I'm just kind of drawing one, okay? So just so you guys see it. That's all you have to do. So are we okay with that page of homework? All right. So again, nothing too exciting. It's just a lot of computations and so on. All right. Next one, match the slope field. So what you guys are going to have to do, they're going to give you 8 different options, okay? And they're going to give you 8 different graphs, okay, 8 different functions. Which one represents y equals to 1? Which one? A. So y equals 1. What's the slope of y equals 1? 0, right? The derivative is 0. So which one has a bunch of zeros everywhere? D, right? That's how you do this. Let's look at 9. Y equals to x squared. Y equals to x squared. Which one seems to look like y equals to x squared? C does. Okay, why? Because it kind of has this shape to it, right? It kind of looks like that. So that's why that's x squared. Which one is y equals to sine of x? Like, give me two options. Which one would be y equals to sine of x? Either B or E. But which one is the right one? Okay, how can I tell that that looks like sine of x? Well, look, it's kind of doing this thing, right? Both of them are kind of doing this thing. They're moving like that. So, which one is it? How can I tell? Well, the way I would do it is say, okay, they want y equals sine of x. So, if they want y equals sine of x, then these are slope fields, which means these represent the slope of sine, right? So what's the slope of sine at 0? Well, the derivative of sine is cosine. And cosine of 0 is what? 0 degrees, it's 1. So which one of these graphs has a slope that looks like 1 at 0? Well, this one looks flat, doesn't it? So that means the derivative there will be 0. This one kind of looks like a positive slope of 1. Right? So, to me, this is my side function. Because I tested a point for the slope of that graph. Okay? That's how you figure out which graphs match which functions. If these are slope fields, they could actually give it to you two different ways. They'll either give you the original function, like this worksheet's going to give you, like y equals sine of x, y equals cosine of x, y equals ln of x. They'll give you those, and they're going to say which one of the graphs is that. Okay, so the way I would do is I take my derivative, and then once I take my derivative, I would pick a couple of points, if I don't know which one, and I'll say, okay, I'm looking for a graph that is maybe undefined at 2. So then I'll look and I'll say, like, is there anything that has 2 with straight lines up and down? Right? Oh, no, nothing. Okay, I'm looking for, and I'll start looking for characteristics for those slopes. And that's how I figure that out. Again, tomorrow you guys will have time in here to do it, so if you're struggling with this idea, then that's okay. But yeah, you have to look at those graphs. Okay? So, like we said, we do know that, like, number 7, for number 7, y equals 1, we know it's going to be this one, right? This is number 7. And we already figured out that sine of x, number 12, has to be this one right here. Okay? Let's try figuring one more out. Let's try... I don't know. Let's try 11. 1 over x squared. Okay? So 1 over x squared. Any guesses? So the derivative of 1 over x squared, right? So let's do that real quick. So dx of 1 over x squared, which is basically dx of x to the negative 2, is negative 2 x to the negative 3. So it's negative 2 over x cubed. Now, notice, at 0, what is my derivative if I plug in a 0? It's undefined, right? Which one has an undefined slope at 0? Well, this one does. Here, this one right here, the slope is 0, so I don't want to do that at 0. This one right here has 0 for its slope at 0, so that's not good. This one here has a 0 slope at 0, so that's not good. This one here has a 1 slope. Notice that one has a slope of 1 everywhere, so that equation is probably y equal to x, right? Because the derivative of x is 1. So that makes sense, but that's not going to help me. And this one here has an undefined slope as well. So I would say it's either A or G. Okay? So now what I have to do is let's test like x equal to 1, because if it's A, when I plug in a 1, my answer should be negative. Like 1, 0, my answer should be negative. You guys see, look at that slope right here. That's a negative slope. Whereas the other one at 1, it has a positive slope. So if I plug in a 1, 0 into my derivative, what do I get? Right here, I get a negative 2. So which one is it, A or G? It has to be A, because A is the one with the negative slope at 1, 0. Get it? So you're just looking for characteristics of the graphs, okay? So A would be number 11. Okay? Last page. Matching slope fields. All right? The way you do this, I know it looks really weird, but you do basically what we just did earlier, okay? So you're going to say, all right, let's start with number, I don't know, 17. Let's just do 17, okay? So at 0, 0, what happens for 17? What's my slope at 0, 0? Oh, actually, you may not be able to see it. Hold on. So what's my slope at 0, 0 for 17? 0. Okay, so since I know that at 0, 0, my slope is 0, it cannot be this one. It could be C, it could be D, and it could be A. So far, I've eliminated 1. Okay, what else do I notice? Well, I noticed that C at 1, 0, the slope is 1. You guys notice that? I'm looking for like special characteristics that I see. So I see that at 1, 0 and at 2, 1 and at 3, 2, I'm getting slopes of 1, right? On the graph. Does 17 match that? At 1, 0, does it give me a 1? 1 minus 0? 1, right? What about at 2, 1? Also 1. What about 3, 2? Also 1. Now, before I just celebrate and say, oh, yay, this is number 17, I got it, I want to check the other ones just to make sure, because what if there's another graph that has that same characteristic? But if I look, this one at 2, 1 has a negative slope, so that's not good. And this one right here for D at 1, 0, it doesn't have a slope of 1, so that doesn't work. It has to be C. Okay, so you do have to plug in numbers, but be smart about it. Don't just start plugging in every single number. Like for me, this right here looks pretty important. I would look to see what function, 15, 16, 17, or 18, always has 0 when x is negative 2. Right? Which function always has 0 when x is negative 2? So I would look. Which one do you think it is? Which one always has a negative 2 no matter, which one always has a 0 no matter what you put in for your y value? Any guess? Notice how B matches vertically. You guys see that? Every slope is identical vertically. Okay, D has slopes that are identical horizontally. We saw that practice in the very beginning. 1 has matching numbers vertically. What's missing in terms of x and y from number 1? Which variable is missing? Say it louder. I know someone said it. The y value. Notice it's x plus 1. If y is missing, it matches vertically. Look at number 2. Which variable is missing? X, and it matches horizontally. So, if B is matching horizontally, which variable should be missing? A Y. Which equation is missing a Y? 15. Okay, it's just, you got to notice these things. They're just little patterns. It's not like you're doing crazy calculations, right? So yeah, this would be number 15. And of course, if you're like, well, what if I don't see the patterns? Well, then calculate the slopes, okay? Calculate a bunch of them, make sure they match up. You can always do it that way. There's nothing wrong with doing it that way. It just takes a little longer. So can you tell me which one is going to be the one that has no X? 16, right? Which would be what? D, because that one matches horizontally. All right? Now, this is the kind of stuff you actually get in your AP exam. So let's do number 19 real quick, and then I'm going to stop. So it says the calculator drawn slope field for the differential function dy dx equals xy is shown in the figure below. The solution curve passing through the point 0,1 is also shown. So notice they call it a solution curve. And it's passing through the point 0,1. They kind of highlight that for us right there. Okay? Sketch the solution curve through the point 0,2. Well, here's 0,2. It's supposed to match up with the previous one, so I'm going to draw it like this. And I'm done. Sketch the solution curve through the point 0, -1. Well, just follow the slopes, okay? So you're going to go like that and just kind of stay within the curves. And there you go. That's it. Easy, right? Pretty easy. Just don't do anything like this. Don't cross through them. Think of this kind of like a river, okay? And the river is going to make the water flow through a specific pattern at all times because rivers have different inconsistencies within the water. But if you notice, rivers, even though it's just a big old bed of water, rivers have specific ways that they flow because of the rocks beneath it. They push the water in certain ways. So even little sections of rivers can flow in different directions, even though they're all going in the same direction, right? So that's kind of the same idea. You can think of this like river currents, right? So you're just saying, well, if I start to go left, like for the bottom function right here, if I start to go left, then the water is going to push me down this way. And if I start to go right, then the water will start to push me down that way. Okay? So just think of it like currents. So tomorrow you guys will get these worksheets and you guys will work on them, okay? I'll send this to you guys today, though, just so you can take a look at it. If you want to print it out at home and start early, then go ahead. But I'll send this stuff out to you guys today.